All right, here we go. So today we're going to talk about section 2.7. I've decided not to do 3.1, at least not today. I'm going to do it on Thursday like I should have. So instead, I'm going to give you guys time to review and ask questions at the end of class if you have any. So for this section, we're going to talk about something called an inverse function. Just like the name suggests, this function is literally the reverse of anything we initially work with. So, for example, if I want you to look at a function f of x, f of inverse is going to be negative of that function, f of negative x. So this is the normal notation we use for a function f of x. And to signify that the function we're dealing with is an inverse of this function, you would write f negative 1 like this of x. So the function itself is inverted. This sign right here is the power of negative 1. That means inverse. And when I say this, I don't mean this is 1 over f of x. These two are not the same. Yes? So it's not 1 over f of x. It's just f to the negative 1 power. Right? Now, before I get into inverse functions even further, I need to introduce you guys to a concept called one-to-one. A function needs to be one-to-one in order for us to find an inverse. So we need to be able to identify what a function when a function is one-to-one or not. So do you guys remember when I said that in order for a function to be actually a function, it needs to pass the vertical line test? Yes. So it only intersects at one point, no more. Well, that vertical line test is the function test. So if I want you to identify if a function is one-to-one or not, it needs to pass another type of test, which is called the horizontal line test. So for example, the parabola I just drew right here intersects the horizontal line at 2 points. Therefore, this is not 1 to 1. It is not. So what is the big deal here? What's the idea? When we want a function to be identified as an actual function, we said that each x value needs to have only one associated y value, right? So when I gave you guys a group of ordered points, what did we say? We said that 1, 3, 2, 3, 4, 2. Right? Is this function or is this relation a function? Yes or no? The answer in this case would be yes, because each x value is different. We have two similar y values, but that's fine. It's not a problem. So this is a function. Well, in order for a function to be one-to-one, each y value has to be different. So not only the x's, but the y's as well. So because we have the same y value mirrored in 2 points, this relation right here is not one-to-one. Yeah? So if I give you the first example in the notes, it's another relation. We have the point 2, 1, another point which is 4, 2, another point which is 7, 3, another one which is negative 2 and 1. Yeah. And now we need to look at the x's. You have 2, you have 4, you have 7, and the negative 2. None of them are similar, so this is a function. Now, is it one-to-one or not? Okay, let's look at the y values. We have a 2 and a 3. Those are not the same, but we have two 1s over here. See that? A 1 and a 1. At the points 2 and negative 2 for x, y is 1. So because, oops, I forgot that. Because of these two right here, this relation is not one-to-one. Okay. Here's another example in the notes. Students usually have fun with this one. I'm going to give you two groups, right? Let's call the first one x, right? And the second one my y. Yes? So x is my superhero group. superheroes, and Y is the villains. Yes? In the superhero group, who did I give you? We have Batman, we have Green Lantern, and we have Wolverine. Okay? So who do we have in the villains? We have Sinestro, the Joker, and Sabretooth. Okay. So since you guys are probably familiar with these superheroes and their villains, which arrow goes where? Let's associate each X value with the correct Y value. Who's the villain for the Batman?
Joker.
Yeah, so the arrow goes here, right? Okay. Who's the villain for Green Lantern?
Sinestro.
So the arrow goes there. And the villain for Wolverine is the remaining one, which is Sabretooth, right? Okay. So now that we look at it like this, as you can see, each Y value is only associated with one X value. So this is 1-to-1. Yes? Okay. So let's call this relation right here f of x. So this is my function f of x, where x is here, y is here. This is your domain, and that's your range. Okay, so what if I want you guys to tell me what would be the domain and range of f inverse of this f of x? Well, in that case, you would flip these two. Here's what I mean. Since for f of x, the superhero group, right, x, superhero group is my domain, for the f inverse is going to be your range. So as far as f inverse is concerned, this is the y. Yes? So it would be right here. It would be y, and it would be the superheroes. Go up a little. And the range of f of x would be the domain of f inverse. So they switch, literally. So x would be the villains. So if I want to copy them exactly, this would be Batman. This would be the Green Lantern. And this would be Wolverine. And over here we have Astro, Joker, and Sabretooth. Right? So this one goes here. I'm reversing what I did just now. And up there. So that's your domain. That's the range. Here, that's your domain. And that's the range. They switched. So from this relation, you can see that the domain of the main function would be the range of the inverse. And the range of the main function would be the domain of the inverse. Okay? They flip. Actually, flip is not the right word. They switch. That's what happens. So now, based on this, let me give you, oops. Another example. But now we're gonna look at graphs, right? I want you to look. This is the notes right here. This is what I was doing. Number 1, number 2. Now over here, we have a few graphs. I'm gonna try to zoom in a little. And we're gonna see if they are 1-to-1 or not. Okay, what about this one? Number 3. Do you think this is 1-to-1? Now, like I said, for 1-to-1, the test we're gonna draw is a horizontal line test. As you can see in the notes right here, I have it written down. Right? So, function is 1-to-1 if no horizontal line intersects the graph at more than one place. So if you draw a horizontal line and it intersects at only one spot, no more, then you're good. So if I draw a line here, draw this point, through this point, for that point, and so on and so forth, it will be clear to see that each point, since it's on its own line, they will never intersect more than one point. So is this one 1-to-1, yes or no? So yes. 1-to-1. What about that one? I pick this line right here and draw a line through. How many times did it intersect? Multiple, right? So we have 1, 2, 3, 4, 5, 6, and it probably keeps going. So this is definitely a no. All right. What about this one? Draw a line here, here, here. Ah, yes. Right. Any questions? Yeah? Okay. Let's get back to it. So identifying if a function is 1-to-1 is pretty easy. But now that we know what it takes for a function to be 1-to-1, which is basically pass the horizontal line test, let's see how we can find out what the inverse of the function is. Because the questions I'm going to give you differ. But in order to understand the relation of the inverse, you need to understand what the inverse function is. So far I told you that the domain and range of the original function and the inverse function are switched, right? Why does that happen? It happens because the inverse function is basically plugged into the original function and it eliminates it. What do I mean by this? For example, say we have a function g, call it g of x, yes? And another one called f of x. I should have written it backwards, but whatever. So f of x and g of x, okay? Different functions. I'm not telling you they have anything in relation yet, just that there are two different functions. Both are 1-to-1. So I'm already telling you that they're both 1-to-1. Okay? If you compose these two together, right? So you grab f and g together, like this. I'm plugging g inside of f, right? This composition means that it is f of g of x. Yes? So if you plug in g of x inside f of x, and after you're done solving, the final result is x, yes? And, because both have to be true, if you plug in f of x inside g of x, yeah? So that means it's g of f of x, like this, and the result is still x, so they still cancel out, still gives you x, then that means then g of x equals f inverse of x. Or f of x equals g inverse of x, whichever one you choose. But that means that these two functions are inverses of each other. So in order for a function to be inverse of another, that means that once you plug it into the original function, the final result is x. They literally cancel everything out, and the only thing you're left with is the x you started with. Make sense? So if they're inverses, they're going to cancel out once you plug them into each other. If they're inverses, the domain and range are switched. Let me show you an example that would clarify this. This is number 8 in the notes. Let's see. So let's say, number 8, you have f of x, which equals what? This equals 3x plus 6. Right? And g of x, which is 1/3 times x minus 2. These are my two functions. Okay? Now, the question is asking you to determine if these two are inverses of each other. Okay? Now, there's two ways to solve this. Two possible ways. One would be to plug one function into the other, or vice versa. But that's the first method. The second method is to simply choose a value and see if it switches from domain to range. I'm going to do both to show you both. Okay, the notes I think only has one of them, but I'm going to do both here. Okay, I'm going to start with the value, since that's the one not in the notes. So to start, you just need to grab a random x value. Let's say x equals 3, for example. Okay. Now for f of x, since I said x is 3, that means I'm going to plug in what value? 3. Okay, so that equals, okay, so 3 plugged in here. 3 times 3 is 9. 9 plus 6, that gives us 15. Right? So f of 3 equals 15, which means that for the f function, the x value is 3, the y value is 15, because that's the result. So I want you to grab this result and plug it into the g function. G of 15. Now, why am I plugging the 15 and not the 3? Because we said that for the inverse of the f function, the y would be the domain. So y would be x as far as g is concerned, if they are inverses. So the point here is that if I grab the 15, plug it into g, and the final answer ends up being 3, then these two are inverses. Make sense? It's going to basically cancel everything you did here. Moving the 3 all the way to the value of 15, g is going to undo that and take you back to the value of 3. That's the point. We'll see if that's going to happen. Here we go. We have 1/3 times 15 minus 2. Okay, so third, or 15 divided by 3, right? 3rd times 15 is going to be what? 5. Correct? Because 15 is 3 times 5. You the 3 cancel and you end up with a 5. 5 minus 2, and the answer is 3. Same number we started with. So based on this, is G an inverse of F? Yes or no? The answer is yes. Did everybody get this one? Any questions whatsoever? Okay. All right. I'll do another one. This time I'm gonna start with G just to make sure it's sunk in. Okay. So now we're starting with G. I'm gonna pick the number something divisible by 3. Let's go with 3. No, actually we did 3 already. Let's do. I wasn't paying attention. Let's do 6. Okay, here we go. Do 6. Okay. So now G of x. Since I'm doing 6, so we have 1/3 multiplied by 6 minus 2. So 6 over 3 is 2. 2 minus 2, the answer is 0. Right? So, oops, this is G of 6. It's not x. So G of 6 equals 0. Now, since the answer I got is 0, that's what I'm going to plug into f. F of 0. And the answer should be 6. Okay. So we have 3 times 0 plus 6. 3 times 0 is still 0, and plus 6, that makes it 6. Answer 6. Same number we started with. See that? So it doesn't matter which direction you take, it will give you the same result. That's the first way. Plugging in a random number and seeing if it comes out at the end the same number after you plug it into both functions. Okay. Second one would be literally grabbing one function, plugging it into the other, and then finding out if the final result is x, which is the definition of an inverse function, what I just talked about. Okay, let's do that. Now, I'm going to do composition between f and g. This is g and f equals. So it's f of this whole function, which is 1/3 x minus 2 g of x, which equals. Now I'm going to plug this whole thing in here. This is going to be 3 times 1/3 x minus 2, and then plus 6. Okay? Now 1/3 gets multiplied in one term to the second term. So multiplying it to the 1/3 x times 3, third and 3 cancel, and you end up with x. 3 times -2, -6. And then you add the remaining 6. And look what we have here, positive and -6. These two cancel out. This is a total of 0. So the final answer is x, just like the definition said. It canceled out, and you ended up with x. So they are inverses. And I guarantee if you do it the opposite way, this is f and g, it'll still give you the same result. Right, for number 8, f and g are inverses. Let's try number 9. So we have what? F of x equals x plus 1 over 5. And g of x is 5x plus 1. Yes? Alright. Now let's see. We have 2 methods. I'm going to do both, but again, you only need to do one of them. You don't need to do both. One of them is enough. I'm going to start with the second one this time. I'm going to plug one into the other and see what happens. Okay? So let's try that. We have f and g of x. That means it's going to be f of g of x. Now, g of x is 5x plus 1. It goes inside. Now, I'm plugging that in here. So you have 5x plus 1 instead of the x on top, plus 1, the whole thing over 5. That I replace the x with 5x plus 1. Now, nothing multiplied here, and we just have an addition. So I can just remove the parentheses. We don't have to care about those. We have 5x plus 2 over 5. Now, this is as far as the simplification gets. Technically, you can split this, and then you end up with x plus 5 over 2, if you want. But that's simply you rewriting. It's not simpler. It's just different. But anyway, this right here is definitely not. But it's not x. Yes. It didn't leave us at x. We still have something left, which means these two are not inverses. Something else that would prove that is if I choose a random value to plug in. So let's say x is 2, for example. So f of 2, plugging it in here. You have 2 plus 1, which is 3, over 5 gives you 3 over 5. So that's the final result. Now, plugging that in here. G of 3 over 5. Okay. So we have 5 times 3 over 5. The 5's cancel, and you end up with a 3. Yes. And then plus the 1. So that's 3 plus 1, which is 4. Not 2. It's 4. Therefore, this is not equal to. So, not an inverse. Any questions, you guys? Okay. I think that's enough. Everybody done writing? Probably wait a little longer. So we just saw together how to identify if two functions are inverses or not. Let's plug one in together and find the answer, or pick a random value and move in both functions, plug it in one, get the answer, plug the answer in the other, and see if you get the same result you started with. Those are two ways to find out if two functions are inverses or not. But what if I asked you to find the inverse? So what if I told you, here's f of x, I'm giving you the question, the function, sorry. So here's f of x, whatever it may be. And then I tell you, give me f inverse of x. How do we find it? Well, this is how. There are 4 steps you need to think of. Number 1, they're in your notes, by the way, if you have them printed. But anyhow, number 1 would be to replace f of x with y. What do I mean by this? I mean, for example, if I had given you f of x equals x squared plus 1, plus 1, instead you write this in the form of y equals x squared plus 1. Yeah? Because it makes it easier to see the operation if it's in the form of one letter instead of f of x. Make sense? So the first step would be replacing f of x with y. And we said that f of x is y, just writing it in a different form. That's all. So we still didn't do much. We just change f of x to y. Second step would be to switch. I want you to switch x and y. Now, what do I mean by this? I mean, in the equation you ended up with, I want you to replace every x you see with y and every y you see with x. Which makes sense because I said that the domain of a function is the range of the inverse, and the range of the function is the domain of the inverse. So I wanted to switch the x and y. So this right here ends up being what? X equals y squared plus 1. See that? Just remove the x and put a y. Remove the y, put an x. So I've been asked before, what if you have more than one x? And you replace all of them. Every x you see becomes a y, and every y you see becomes an x. You don't change the equation, just the letter. Yes? Third step would be to solve. I want you to solve for y, because now you have an equation in terms of x. Rewrite this, resolve, so that it would be y equals again. And once you're done, number 4 would be replace the y with f inverse of x. Okay, so those are our 4 steps. Remove f of x, place a y. Switch x and y, solve for y, and then remove the y and put f inverse instead. Okay? Let's try to do that together. Everybody got these down? Okay. I think that's yes. And just to make sure everybody's here and that I'm not disconnecting anything, how's the connection for everyone? Good? Can you hear me? See? All good? Not lagging or anything?
It's good for me.
Okay, good. I'm good here. Awesome. Okay. So if someone's having trouble, let me know. Right, here we go. Okay, so let's do the first example together. Oops. There you go. Right, so this would be example number 10, the notes. There you go. Number 10. So for number 10, the function given to you is the following, f of x, which is 2 plus 1/2 times x. Right? So this is what? A linear. I mean, I know you see a half, but it's still linear. X is the power of 1, it's not under the denominator, it's not under root. So it's a linear equation. Okay. Now we need to find f inverse. So we'll follow the steps I just told you. Here we go. Number 1, I'm going to replace f of x with y. So doing that, this function looks like this. Y equals 2 plus 1/2 x. Oh, oops, do this. Okay. Number 2, I'm going to switch the x and y. And y. So we end up with x equals 2 plus 1/2 y. See what I did there? Okay. Number 3. Well, I'm going to write it here so we have more room. Number 3. Solve for y. Okay, so you grab the last line you just wrote, which is x equals 2 plus 1/2 y. We're going to solve for y. Now, first step, I want to get rid of anything else that's not multiplied here. So you grab the 2 and you move it to this side. Turns negative. So you end up with x minus 2 equals 1/2 y. So since I have a half and I want to get rid of it, I'm going to multiply by 2 on both sides. Half with the 2 cancel out. And the 2 that gets distributed in, and you get what? 2x minus 4 equals y. This is our final result. We just solved for y. Done. Now, number 4, last step, would be to replace y with f inverse of x. So this turns into f inverse of x equals 2x minus 4. This right here is the inverse function of the one we started with. Just that one. Okay. Now, since I taught you guys the definition of an inverse, that's an easy way for us to check to see if you got it right or wrong. Because, I mean, you could have gone wrong somewhere along the way. So one way to always check your work, I'm going to do it here. To check, you can always grab the function you started with and the inverse you found, plug them into each other, and see if the final result is going to be x. If it is, then you got it right. Let's try that. So I'm plugging this into the original function. The original function, it was x plus 1/2, 2 plus 1/2 x. So instead of the x, I'm placing this entire thing, which is 2x minus 4. Okay, 1/2 times 1/2 times 2x gives you just x. And 1/2 times the negative 4 becomes a negative 2. Positive 2, negative 2 add up to 0, and the final result is just x. We're good. Okay, so this is a way to check. Now, I won't ask you to do this on test, but this is just for you if you want to check your work, or if you aren't sure you got it right or wrong. Okay? Any questions? So 1. There you go. Let's do another example. This one's a fun one. So stay with me. Here we go. This question is number 11. It's irrational. X equals 3x over x plus 1. Okay. Now, let's find the inverse function. Number 1, replace f of x with y. It becomes y equals 3x plus 1. Oops, plus 1. Looks like an H. All right. Number 2, switch x and y. So we have what? X equals 3y over y plus 1. Saw that? I switched both x's to y's. Step 3, solve. Okay, so to isolate y, I first need to get rid of the fact that one of them is in the denominator. So to do that, I'm going to multiply by y plus 1 on both sides. So it becomes y plus 1 here times the x, and it equals the 3y on the other side, because the y plus 1 canceled with the bottom. So this is just to show you the step we did. Right? So multiply y plus 1 on both sides. These cancel, and on this side you end up with the multiplication. Okay. Now, next thing you can do is basically multiplying the x in. Yes. So once you do that, you end up with what? X times y, so that's xy, and then x times 1, so x. Yeah? Okay. And on this side, we still have 3y. Now, I've been asked before, why are we doing this? Why can't I just divide by 3 and be done with it? It's because we still have a y over here. One side has to have y, and the other side has to have everything else but the y. Make sense? So I'm trying to get all the y's on one side. Now we have xy plus x, and it equals 3y. Now the next step you need to do is move this term right here to that side. Now I'm moving, I'm not dividing or multiplying, simply moving. Yes? So xy becomes negative xy. On this side we still have x, and over here we have 3y minus xy. Now I'm going to take y as a common factor, factor it out. So just like we had x as a common factor here and we multiplied in, now I'm doing the opposite. I'm taking the y out. So when you take the y out, you're going to divide everything on the inside by y. 3y divided by y gives you 3 minus xy divided by y gives you x. And on this side, we still have x. Final step, I'm going to divide by 3 minus x because I need to isolate the y. So anything else multiplied by it, it's divided by on both sides, just so these would cancel. So over here you have 3 minus x. And with that, we are done. Y equals x over 3 minus x. As you can see, that is your inverse function. So we finished solving for y. Now don't forget step 4, where you replace y with f inverse. So I'm going to write minus 1x equals x over 3 minus x. That's your inverse. Did everybody follow that one? Any questions? Understandable. That's good. What was I gonna say? Yes. If you want me to do it again, I'd be happy to. If there's a part that you struggled with or didn't catch what I there, let me know. You want me to do the check? You want me to show you how to plug both into each other, since it seems like a fun problem? I usually get a yes, but some people say no, thank you. So I'm not sure if you want me to. Like I said, you don't have to, but it's, yeah? Okay, let's do it. So I'm gonna check over here. So I'm gonna go up all the way there. Now again, to check, you plug one function into the other to see if the final result is x. So I'm gonna plug the inverse into the original function. Okay, so here you go. This equals. Now, the original function is 3 times x, so I'm gonna leave a big blank here, over another x plus 1, right? So in here, f inverse goes, which was x over 3 minus x. It's x over 3 minus x. X over 3 minus x. This is what we're trying to solve. Now just try to simplify as much as possible to see if you get what we think should be received. Okay, now if you notice, on both sides, like the top and the bottom, if you had this alone and you want to get rid of the bottom, what would you do? You'd multiply by 3 minus x, correct? And for the bottom, it's the same case. Multiply by 3 minus x. So I'm going to multiply by 3 minus x, top and bottom. So if I do that, 3 minus x, 3 minus x, I'm essentially multiplying by 1. So nothing is really changing the equation. Make sense? So I'm multiplying by 3 minus x on top and the bottom. So on top, you end up with 3 times x over 3 minus x times 3 minus x. So these are obviously gonna cancel, and you end up with 3x. That's the top. For the bottom, you have x, 3 minus x, right? Plus 1. There's an addition here. The whole thing gets multiplied by 3 minus x. Yes. So you end up with what? You get 3 minus x times this 3 minus x, which cancels. I'm going to start a new line. Top, we said, is just 3x. Now at the bottom. So this multiplied by this fraction right here, 3 minus x and 3 minus x cancel, and then you end up with just x plus, now the 1, times 3 minus x, and you end up with 3 minus x. Okay? So this is what we have in the bottom now. Okay. So you have positive x. This is addition, so there's nothing to worry about here. You have positive x and the negative x. They're gonna cancel with each other. And you end up with 3x over 3, which is just x. Who found that one fun? Just wondering. That was one way to solve it, obviously. You can always do it backwards. So basically plug f of x into the f inverse, but it will give you the same result anyway. All right? Any questions? I'm going to take that as a no. Okay. So, okay, awesome. Now that we're done with this one, let me move on to number 12. Okay, so far, as you've noticed, we did a rational function and a linear. But what if I gave you this? Oops, there we go. Number 12, we have a quadratic. The f of x the question gave you is x squared plus 3. Now, can you find the inverse for this function? I just want the yes or no answer. What do you think? Quadratic. Can we find the inverse? Well, here's a hint. The answer is no, because it intersects at 2 points. While this is a function, it's not one-to-one. Remember, in order for a function to have an inverse, it has to be one-to-one. Because we are flipping the range, switching the range and domain. So you can't have one y value that has 2 x values, because once you switch it, then you're going to end up with one x value that has 2 y values, which makes it not a function. Make sense? So you can't have an inverse to a function that is not one-to-one. But if I give you a detail such as this one, for example, then you can. Why? Because I basically cut your domain in half. So instead of this quadratic function being from negative infinity to positive infinity, I'm basically telling you, just look at the positive side. So I'm not looking at this part of the domain. I wanted to exclude it from the function. So I'm talking about this function only if x is equal to or bigger than 0, which means it starts here and goes to infinity. In that case, it's only this half right here, and that line only intersects once. So we can find the inverse of this function. Okay? So with that half in mind, let's solve. Let's find the inverse for a quadratic. Here we go. Step number 1. Y instead of f of x. So it becomes y equals squared plus 3. Step 2. Switch x and y. So you get x equals y squared plus 3. Step 3. We're going to solve. So here we go. X equals y squared plus 3. I'm going to grab the 3, move it to the side, and it turns negative. We have x minus 3. It equals the y squared. Okay. Now I want to get rid of the squared. So I'm going to take the root. So y equals root of x minus 3. There. Replace y with f inverse of x and equals root of x minus 3.
Froze.
Good.
Yeah.
You saw.
Last thing I saw was the y equals root x minus 3.
Okay, good. That was the root. After that, just f y with inverse. I'm going to turn it off and see if I can turn it back on. Hold on. Look at my platform. Can you hear me?
Say again?
Can you see me? It's showing me I'm offline. Okay. So it's still connected. That's good. Yeah.
All right. Audio sounds fine.
Let's try again. Here we go. So how does this look? Is it working now?
Yeah.
Okay. Yeah. Right. Awesome. So as you saw, I just replaced the y with f inverse. And that's our solution. Now, there's a question I usually get. It's like, why is it that when I did the root, I took the root of both sides, why didn't we write positive and negative over here? Because if you remember the rule I said, I always say if you take a root of something, you're going to have to add positive or negative to the value under the root, and if it remains under the root, then you write the plus or minus outside, because what? Because anything you square could have possibly been negative, correct? So why didn't I do it here? Well, the answer is easy. It's because when we started solving, we initially said that x has to be equal or greater than 0. By saying this, I eliminated the negative possibility. So I actually can't write positive and negative. It has to be positive. Otherwise, it's not within the domain I'm talking about. Make sense? But yeah, that's the inverse. Any questions at all, you guys? All good? We have one more problem and then we're done. This one is actually from the notes. So I'm going to show you the page from the notes right here. Question number 13. As you can see the graph, I only gave you a graph of the function and didn't give you what the function is. And I want you to graph the inverse. Okay, but to do that, we need to know what the points are. So here we go. So this function right here, which is, let's look at the points for the blue function, which is f of x. So we have, let's start here, -4 for x and -2 for y. So it's the point -4 and -2. And then we have -3 and +1. So -3, +1. And then we have -1 and +2. -1 and 2. And the last one is +1 and +4. 1 and 4. So that's my f of x. So what is my f inverse? Hint, range domain. For the inverse functions, they are what? They are switched, right? So that means that all my x's, as far as f inverse is concerned, all my x's are going to be my what?
Y's?
Yes, because the domain of this is going to be the range of the other. Exactly. So that means that all these x values are going to be written as y values, and all the y values are going to be written as x values. So -4, -2, it becomes -2, -4. -3, +1, it becomes 1, -3. -1 and 2 becomes 2 and -1. And 1 and 4 turns into 4 and. Yeah. So let's plot those points. Okay. So starting with this one, you have -2 and -4. So -2 for x, -4 for y. So it's going to be right here. Wait. Yeah. -2 for x, -4 for y, right here. Yeah. And then we have +1, -3. So x is 1, y is -3, so it's right here. And then we have +2 and -1, so 2 and -1, which is right here. And then we have 4 and +1, so 4 and +1. So please do that. Does this? It does. They're mirrored. Notice? Any questions, you guys? Still there? Didn't cut off again, did I? Oh, that looks fine-ish.
Still here.
Awesome. You don't sound happy about that, though. But yes, okay, good. Any questions? Okay, so want me to go over the quiz?